Imagine this. You're standing outside on a quiet night, looking up at the vastness of the cosmos. The stars, galaxies, and nebulae paint the sky with their ancient light. The darkness between them seems infinite, almost comforting in its stillness. But what if that very darkness was hiding something? What if there was a place in space where light doesn't just fade away, but disappears entirely? What if the darkness itself was alive, a presence so strange that it could bend the very fabric of reality? This is where the story of the dark star begins, and let me tell you, it's a tale that challenges everything we think we know about the universe. Now, when most people think of dark stars, they probably picture black holes. After all, we've all heard about these mysterious cosmic giants, regions in space where gravity is so intense that not even light can escape. But what if there was something even stranger, something more elusive, yet potentially just as destructive to our understanding of physics? Something that doesn't just trap light, but consumes it in a way we can't yet fully comprehend. The dark star isn't a black hole, but it might very well be the universe's dark predecessor to these cosmic monsters. It's a theoretical concept, something that exists in the realms of science fiction, or at least it used to. In fact, it challenges the way we view stars, light, and the very forces that drive the universe itself. What makes the dark star so fascinating is its sheer complexity. On the surface, it sounds like just another kind of star, one that's as distant and cold as the rest of them. But when you dig a little deeper, you realize it's anything but ordinary. This star would not burn with the familiar shine of nuclear fusion like the sun. It wouldn't cast its glow across the night sky. Instead, it would consume light itself, taking us to a place where darkness has a kind of substance and purpose. The first thing you need to know about the dark star is that it's theoretical, at least for now. Its existence has been proposed by astrophysicists to explain some of the earliest and most mysterious phenomena in the universe. Scientists believe that just after the Big Bang, in the infancy of the universe, conditions were vastly different from what we see today. The elements that make up stars, hydrogen, helium, and heavier elements like carbon, hadn't yet come together in the same way. Instead, the cosmos was filled with vast clouds of pure hydrogen and helium. No stars, no galaxies, just a primordial soup. In this early universe, things were about to change in ways we could never have imagined. This is where the dark star enters the picture. Under normal circumstances, when a star is born, it begins as a gas cloud. Gravity pulls the cloud together, and as the gas compresses, it heats up. When it reaches a certain temperature, nuclear fusion ignites, and the star starts to shine. But the dark star, this strange cosmic entity, would not behave like the stars we know today. You see, the early universe wasn't just filled with gas, it was also full of dark matter. And dark matter, as mysterious as it is, plays a crucial role in the life of the dark star. Dark matter doesn't interact with light the way ordinary matter does, but it still has mass. And mass, as we know, creates gravity. So imagine a scenario where gravity isn't just pulling hydrogen and helium together, but it's also interacting with dark matter. The result is an entirely new type of star, one that doesn't rely on the usual nuclear fusion process. Instead, the dark star is thought to have been powered by the annihilation of dark matter particles. These dark matter particles would collide and release energy in the form of heat that's enough to sustain the star's expansion. But here's where things get really wild. The energy that powers the dark star isn't the kind we typically associate with stars. It's not visible light. It's not ultraviolet radiation. It's a different kind of radiation, one that doesn't interact with regular matter in the same way. This means the dark star would be invisible to our eyes, at least in the traditional sense. Instead of shining in the way our sun does, a dark star would be dark in the truest sense. It wouldn't cast a glow, and it wouldn't illuminate the surrounding space. Instead, it would only radiate in wavelengths that are invisible to us. Imagine a cosmic object that, while theoretically a star, doesn't produce the kind of light we are accustomed to. Here it's almost as if it exists in the shadows of the universe, hidden away in plain sight. The next question you might be asking is, why is this so important? Why does it matter if a star doesn't shine? Well, this is where the stakes get higher. Understanding the dark star could hold the key to unlocking some of the most profound mysteries in modern physics. If we can confirm its existence, we would be staring straight into the heart of early universe conditions, and possibly even dark matter itself. But the dark star's story doesn't end with its birth. There's something even more fascinating and unsettling about these objects: their death. When the dark star reaches the end of its life, the theory goes that it would collapse under its own gravity. But instead of going through the typical red giant phase that we see in ordinary stars, a dark star could collapse into a supermassive black hole. In essence, the dark star might be the progenitor of the very black holes we observe at the centers of galaxies today. Think about that for a moment. What if the supermassive black holes we see in places like the center of our own Milky Way galaxy, objects millions or even billions of times the mass of our Sun, had their origins in the mysterious dark star? What if the very first black holes weren't formed from the collapse of ordinary stars, but from these strange dark predecessors? And here's the kicker: we have no direct evidence of a dark star ever existing. Not yet, anyway. Despite their theoretical importance, no one has ever observed one of these objects. But that doesn't mean they aren't out there. Every new discovery, every new theory brings us a little closer to finding the evidence we need. But we're not there yet. So, why are scientists so obsessed with the idea of the dark star? Why do they keep pushing forward with this theory, despite the lack of direct evidence? Because the potential is enormous. If the dark star is real, it could provide answers to some of the most fundamental questions about the universe: how it began, how it evolved, and what forces shaped the first galaxies and black holes. And who knows what else we might uncover along the way. To understand the dark star, we have to go back, not just back in time, but to a time when the universe itself was still in its infancy. Imagine this: a universe that's only a few 100,000 years old, still sizzling from the heat of the Big Bang, the very first moments of creation. It's a place so different from the universe we know today that it's almost impossible to imagine. Back then, there were no stars as we know them. No sun, no earth, just a vast empty sea of hydrogen and helium gas, elements formed in the chaos of the Big Bang. The universe was dark, cold, and primitive. It was a time when the first structures of the cosmos, galaxies and stars, had yet to form. But the seeds of those structures were there, waiting to sprout. This is where the story of the dark star truly begins. The early universe was teeming with energy, yes, but it wasn't quite the same as today. The crucial difference was the presence of dark matter. If you've ever heard of dark matter, you probably know that scientists still don't really know what it is, only that it makes up about 85% of the mass in the universe. That's right, 85%. It doesn't emit light, it doesn't interact with electromagnetic forces, and it doesn't show up on ordinary telescopes. But dark matter has mass, and mass causes gravity. And gravity, as we know, can shape the very fabric of space itself. In the case of the dark star, this mass and gravity were crucial to its formation. Without dark matter, the dark star would not have been able to form. The gas clouds of hydrogen and helium that filled the universe back then were still too diffuse to collapse under their own gravity alone. But as dark matter drifted through the cosmos, it began to accumulate in certain regions, increasing the density of the gas and helping it collapse faster than normal matter could. Now imagine a gas cloud, no ordinary one, but one that's been subtly influenced by the invisible presence of dark matter. The hydrogen and helium within this cloud start to compress. But instead of forming a normal star that ignites through traditional nuclear fusion, this cloud of gas doesn't burn in the usual way. It's too cold, too different from the stars we're familiar with. Instead, it begins to heat up, but not through fusion. This heating is caused by dark matter. You see, in this early universe, dark matter wasn't just a passive presence. In fact, the most recent theories suggest that it actively participates in the creation of the dark star. As dark matter particles collide with each other inside the collapsing gas cloud, they annihilate each other, releasing energy in the process. This energy isn't in the form of visible light, though. It's a strange invisible radiation, radiation that doesn't behave like the light we see from normal stars, and it's this unique form of energy that allows the dark star to grow. The gas cloud isn't heated by fusion like the sun, but by dark matter annihilation. It's a cosmic paradox, a star that doesn't shine but grows through an invisible force. So what happens next? As this primordial gas cloud continues to collapse under the influence of gravity and dark matter, it begins to heat up to unimaginable temperatures, hundreds of thousands, even millions of degrees. As the gas gets hotter, it begins to expand, forming a massive star-like object. But this isn't your average star. This is a dark star, massive, invisible, and driven by the strange forces of dark matter. And here's the most mind-blowing part. These dark stars weren't small. In fact, they could have been hundreds of times more massive than our Sun. These were behemoths of the early universe, objects so large that their very existence challenges everything we think we know about stellar formation. If you could somehow see one, it would dwarf anything we see in the night sky today. And yet, they wouldn't be visible in the way a normal star is. But how could something so massive not be visible? The answer lies in the type of energy it emits. Dark stars wouldn't shine in the traditional sense. Instead of glowing brightly, in the visible spectrum like our Sun, their heat would be radiated in wavelengths that our eyes can't detect. They would glow in infrared, or perhaps in completely different parts of the electromagnetic spectrum. In essence, they would exist in the shadows, unseen by the naked eye but powerful beyond measure. These stars, though invisible, would be incredibly important. They were the first true stars of the universe, marking the dawn of cosmic history. Their birth set the stage for the formation of galaxies, black holes, and eventually the universe as we know it. But the most profound aspect of the dark star is that it wasn't just a star. It was a cosmic laboratory. The first dark stars may have been the incubators for the first black holes. In fact, the theories suggest that the dark star didn't end its life as a typical star would. Instead of shedding its outer layers and turning into a red giant, these massive dark stars could have collapsed into a supermassive black hole, becoming the kind of black holes that we see at the centers of galaxies today. The very first supermassive black holes might have been born from these enigmatic dark stars. Imagine the scale of this. The collapse of a dark star into a black hole would be a cataclysmic event. The star would collapse under its own gravity, compressing everything into a singularity, an infinitely small point of mass where the laws of physics break down. But instead of a small black hole, we're talking about a supermassive one, potentially millions or even billions of times the mass of the Sun. This isn't just the birth of a black hole, it's the birth of galaxies themselves. The gravity of these supermassive black holes would help pull in gas and dust, creating the very first galaxies. And as these black holes continued to grow, they would become the cosmic giants at the heart of each galaxy, their gravity bending light and time around them. But here's the catch, this is all theoretical. We have no direct evidence of a dark star ever existing. Yet the evidence we do have, the way galaxies and black holes are distributed across the universe, the cosmic microwave background radiation, and the strange phenomena that occur near the centers of galaxies, suggest that dark stars could very well have played a pivotal role in the early universe. The search for these ancient, invisible stars continues. With powerful new telescopes like the James Webb Space Telescope, JWST, scientists are peering deeper into the universe than ever before, searching for the faintest traces of these long-gone objects. Will we ever find proof that the dark star existed? Only time will tell. But as we explore the furthest reaches of space, the mystery continues to grow. As we venture deeper into the mystery of the dark star, we find ourselves standing at the crossroads of cosmic history. These enigmatic objects, born from the earliest days of the universe, weren't just the precursors to black holes. They were the very foundations of the structures that would define the universe we know today. To truly understand the legacy of the dark star, we must step back and explore what it means for the cosmos. Let's think for a moment about the chain of events that unfolded after the birth of the first dark stars. These stars, immense and shrouded in darkness, were more than just stellar objects. They were the seedbeds of cosmic giants. For billions of years we have lived with the cosmic aftermath of their existence. When these first dark stars collapsed under their own gravity, they didn't just leave behind a trail of destruction. They laid the groundwork for the most massive and mysterious objects in the universe, supermassive black holes. To understand the true significance of this, we need to consider the role of supermassive black holes today. At the heart of every major galaxy, including our own Milky Way, sits a supermassive black hole, an invisible, mind-bending region of space where gravity is so intense that it warps time and space itself. The one in the center of our galaxy, Sagittarius A, has a mass around 4 million times that of the Sun. But here's the question: how did these supermassive black holes come to be? Where did they come from? This is where the dark star's legacy comes into play. The leading theory is that supermassive black holes didn't form from the collapse of ordinary stars, but rather from the collapse of the dark stars themselves. Imagine, if you will, the end of a dark star's life. Instead of simply dying like our Sun would, expanding into a red giant and then shedding its outer layers, the dark star would collapse in on itself. Its immense gravity, enhanced by the energy from dark matter, would force the gas and matter at its core into an incredibly small and dense region. This process wouldn't just form a typical black hole, it would form a supermassive one, and that in turn would help shape the formation of galaxies. The birth of these supermassive black holes is a truly cosmic event. As they grew in mass, their gravity would have been so powerful that they would begin to pull in the surrounding gas and dust, helping to form the first galaxies. Picture this: vast clouds of gas swirling around the black hole, spiraling inwards as they heated up, emitting X-rays and other high-energy radiation. Over time, the black hole would not just be a point of infinite gravity, it would become the heart of a galaxy, a gravitational anchor that would influence the formation of stars and planetary systems. These supermassive black holes would go on to shape the evolution of galaxies. Their gravitational pull would influence the movement of stars and gas within galaxies, causing them to cluster around the black hole. In some cases, these black holes would continue to grow, consuming more and more material, while in others, they would remain dormant, quietly affecting the galaxy's structure without becoming active. But here's where it gets even more intriguing. These black holes might hold the key to some of the most profound questions in astrophysics. For years, scientists have wondered about the connection between the growth of black holes and the formation of galaxies. Why do we see such large black holes at the centers of galaxies? And what role did they play in shaping the early universe? One possibility is that the dark star's collapse into a supermassive black hole played a key role in regulating the growth of galaxies. The immense gravity of these black holes could have prevented the galaxies around them from growing too large, serving as a kind of cosmic governor, ensuring that the universe didn't spiral out of control. This would have allowed the galaxies to grow in a controlled fashion, leading to the intricate, vast structures we see today. The idea that dark stars are the ancestors of supermassive black holes also raises questions about the very nature of dark matter itself. Remember, it was dark matter that helped fuel the birth of the dark star in the first place. Without dark matter, these objects would never have formed. But dark matter, as we've discussed, is one of the most mysterious substances in the universe. We don't fully understand it. We don't know what it's made of, how it interacts with regular matter, or why it seems to dominate the universe's mass. But what if the secret to understanding dark matter lies hidden in the remnants of the dark star? After all, it was dark matter that allowed the dark star to shine. If we can learn to understand how dark matter functions in these early cosmic epochs, we may unlock the key to understanding one of the greatest mysteries in modern physics. Could the dark star, in its death and subsequent transformation into a supermassive black hole, hold the key to revealing the true nature of dark matter? Let's take a moment to consider what this means for the future. If we could uncover more about the dark star, whether through observations of ancient galaxies, through advanced simulations, or through the detection of faint signals from the early universe, what could we learn? Could we finally unravel the mysteries of dark matter? Could we learn how supermassive black holes formed, and, in turn, better understand how galaxies took shape? These questions have driven astronomers and physicists for decades. But the hunt for answers is far from over. Thanks to next-generation telescopes like the James Webb Space Telescope, we're able to peer deeper into the past than ever before. Webb's infrared capabilities could allow scientists to detect the faintest traces of the very first galaxies and stars. If we're lucky, we might even be able to find evidence of the dark star itself. Perhaps we'll find a faint, distant glow from the birth of the first black holes or some subtle imprint left by dark matter. But for now, the dark star remains a cosmic enigma, one that exists mostly in the realm of theoretical physics and simulations. And yet, as we continue to push the boundaries of what we know, the mystery of the dark star beckons us to keep searching. The universe is full of surprises, and the more we learn, the more we realize just how much we still don't know. Perhaps, one day as we uncover the true nature of these invisible stars, we'll come to understand the universe in ways we never thought possible. But until then, the dark star will continue to shine, hidden in the shadows, waiting for us to find the answers that lie within. As we approach the end of our cosmic journey, we're left with a burning question. What's next? After all, the story of the dark star may be a story of the past, but it's also one that holds profound implications for our future. As we look to the stars and to the vast, uncharted reaches of the universe, what new discoveries might the dark star inspire? And could we, the inhabitants of a tiny blue planet orbiting a rather average star, ever come to understand these cosmic mysteries in a way that completely transforms our view of reality? In many ways, the search for the dark star is the search for the origins of everything we see around us. The dark star represents the birth of cosmic structure, the point at which the first galaxies, stars, and black holes began to take shape. Its legacy is hidden deep within the vast framework of the universe, in the heart of galaxies, in the black holes that rule the cosmos, and in the very fabric of space-time itself. Understanding the dark star isn't just about unraveling the history of the universe. It's about uncovering the building blocks that form the foundation of everything we know. But there's a deeper mystery here that transcends even the scientific pursuit. The dark star challenges our imagination. It forces us to ask the questions that have always haunted humanity. What is out there, beyond the limits of our current understanding? Are we, as a species, truly on the cusp of something profound? Or are we still standing at the edge of an infinite void, gazing into the unknown, trying to make sense of a universe that defies comprehension? As we uncover more about the dark star and the mysteries it holds, we are faced with the possibility of entirely new realms of discovery, realms that could fundamentally alter the way we perceive the universe. Just think about it. Could there be other, even more bizarre forms of cosmic objects that we haven't even begun to imagine? If dark matter played such a crucial role in the formation of the first dark stars, what else could it be hiding? Could it give birth to new types of stars, galaxies, or even life forms that exist in realms far beyond our current reach? And then, there's the question of our own place in the cosmos. The universe is vast, so vast, in fact, that we can barely begin to grasp its true scale. We are but a small, fragile speck in the grand tapestry of space and time. But what if we are on the brink of a new age of exploration? What if our search for the dark star, and for other mysteries like it, could lead us to a new understanding of the cosmos, and perhaps even of ourselves? As astronomers and physicists push the boundaries of what we know, they are uncovering more than just facts. They are unlocking the very essence of our existence. The search for the dark star is a reminder that we, too, are part of something much larger than ourselves. In our quest to understand the universe, we are not just searching for answers to scientific questions. We are searching for our place in the cosmos. But the road ahead is long, and the mysteries are still countless. From the dark reaches of space to the very particles that make up the fabric of reality itself, there is still so much we don't know. The dark star may be a relic of the past, but it is also a beacon for the future. It calls us to keep searching, to keep questioning, to keep pushing the limits of human knowledge. It tells us that the universe is not a static, known entity. It is a living, breathing, ever-evolving mystery, waiting for us to discover its secrets. And so, as we conclude our journey into the unknown, we are left with a sense of wonder, A wonder that stretches far beyond the facts and figures. The dark star is more than just a chapter in the story of the universe. It's a symbol of the boundless curiosity that drives us to explore, to question, and to reach for the stars, even when the answers remain just out of our grasp. So, what lies ahead? We don't know. But that uncertainty is the very essence of the adventure. We are only beginning to uncover the true story of the cosmos, and in that journey, the dark star will forever remain a symbol of the unknown, a reminder that the universe is full of secrets, and we are just at the beginning of uncovering them. If you've enjoyed this cosmic journey into the depths of the universe, don't let the story end here. Share your thoughts, your theories, and your questions in the comments below. Let's continue this conversation about the mysteries of the universe together. If this video has sparked your curiosity, give it a like and share it with others who are just as fascinated by the unknown as you are. And remember, whether we're looking at the stars or searching for the answers to the greatest questions of all, one thing is certain: the adventure is just beginning.